Hello, viewers. Welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal, and today we are going to study averages. So, this is part 2 for averages, and in the part 1, we have studied the concept of averages and we have also seen the important formulas that is related to averages. So, today we are mainly going to focus on solving problems. So, question number 1. The average of first 101 dash numbers is equal to 102. So this is a fill in the blanks question and we have to identify whether it is odd, even, perfect square or a natural numbers. We are actually taking first 100 numbers. What kind of 100 numbers should I take? Its average is such that its average is 102. So now recall the concept. Average of first n even numbers is equal to n plus 1. So the answer should be even. So that means option number B. So the average of first 101 even numbers is equal to 102. Moving on to problem number 2. If average of 29 consecutive even numbers is 446, then find the difference between first and the last number. So we have 29 consecutive even numbers and its average is 446. Then what will be the difference between the first and the last number? That is what we are interested in. So first of all, recall the concept that we are going to use here. So the concept says the average of consecutive odd number of terms in an arithmetic sequence is equal to the middle term. So we are given that the average is 446. So 446 is going to be the middle term. And it is also given that there are 29 consecutive even numbers that we are talking about. So since one of the term is 446, so since it's the middle term, so 14 numbers will be there on the left and 14 numbers will be there on the right. And we have to add 28. Okay, and the total gap between minus 28 and 28 is 56. So the correct option should be 56. Let us now move ahead to question number 3. The sum of 7 consecutive even numbers is 532. So we have 7 consecutive even numbers and its sum is known, that is 532. So what is the average of first 4 consecutive even numbers of the same set? So we are taking the first 4 numbers out of these 7 and the sum of these 7 numbers is given to us. So let us first quickly recall the concept that will be useful here. First of all, the average is equal to sum of observations upon total number of observations. Secondly, average of consecutive odd numbers of term in an arithmetic sequence is equal to middle term. And thirdly, average equal to first term plus last term upon 2. So 76 is the middle term because there are odd number of observations. 7 observations are there. So 76 will be the middle term. And also one more thing is given, that is it is even number of even numbers, sequence of even numbers. So since the middle term is 76 and there will be 3 terms on the left and 3 terms on the right. So what are all 3 terms on the left? And we know these numbers are consecutive and also even. So what is a very next number to the 76 on the left? and that is even. That will be 74. And moving more left towards 7 from 74, the even number, first even number that comes is 72, and next will be 70. So what is asked here? We are interested in finding the average of first four. Okay. So first term plus fourth term divided by 2. So it will be 70 plus 76 equal to 73. So the correct option should be option number D, 73. So let us move ahead to question number 4. So what is the average of all the numbers between 100 and 200 which are divisible by 13? So there are a lot of numbers between 100 and 200, correct? But we are only interested in numbers that are divisible by 13. So first we have to identify what are such numbers which satisfy this property. So first of all, let me quickly recall you the concept that will be useful here. The average equal to first term plus last term upon 2. So the terms in between 100 and 200 which are divisible by 13 are as follows: 104, 117 and 195. So 104 is the first term between 100 and 200 that is divisible by 13, and 195 is the last term between 100 and 200 that is divisible by 13. So the average will be given by first term plus last term upon 2, which is equal to 104, that is the first term, plus 195, that is the last term, and dividing it by 2, we will have 149.5. Which digit is missing in the average of the numbers 9, 99, 999, 4 times 9, and so on, and 9 times 9? So this is a set of numbers observations is given to us, and we have to find which digit does not occur in the average. So the concept that will be used here will be, if you take the sum 1 plus 1 1 plus 3 times 1 plus 4 times 1 plus dot 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 plus 9 times 1, and if you take the sum of this sequence, you will have 1 2 3 4 5 6 8 9. Okay, so now we are going to use this thing to obtain the average of 9, 9 9, 9 9 9 9, and so on till 9 times 9. So the average of this sequence that is initially given to us is 9 plus 99 plus 999 plus 4 times 9 plus 9 times 9 till 9 times 9, and total number of observations are 9. So I can take 9 common, and then it will be equal to 1 plus 1 1 plus 3 times 1 plus 4 times 1, and so on till 9 times 1. And by 9 times 1 I means 1 repeated 9 times, not actually 9 into 1. Okay, so 9 and 9 get cancelled, correct? And the sum is already known to us, which is equal to 1 2 3 4 5 6 8 9. So it is very easy to see that the digit that is missing in the average is digit 0. So 0 is not in the average. So the correct option should be option number A, that is 0. Let us move ahead to question number 6. The arithmetic mean of the following numbers. So the a set of numbers is given to us: 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 5, 5, 5, 5, 5. Similarly, 6, 6, 6, 6, 6 times 6, and 7 times 7. So this observation is given to us, this set of data points is given to us, and we have to find the arithmetic mean. So the concept that will be useful here will be, if the average of n1 numbers is a1, the average of n2 numbers is a2, the average of n3 numbers is a3, and so on, then the average of total numbers will be n1 plus n2, n1 and 2 will be n1 a1 plus n2 a2 plus n3 a3 plus dot dot dot, and it will be divided by n1 plus n2 plus n3 dot dot dot. So the first sum of first n natural numbers is n times n plus 1 upon 2, and sum of squares of first n natural numbers is n times n plus 1 times n 2n plus 1 upon 6. So these are some useful concepts that will be useful here. So the average will be equal to 1 plus 2 plus 2, 3 plus 3 plus 3, and 4 plus 4 plus 4, 4 plus 5 plus 5 plus 5 plus 5 plus 5 plus 6 plus 6 plus 6 plus 6 plus 6, and 7 times added 7. And in denominator, we will have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, because this is the number of observation, because 1 occurs one time. Okay, so 1 2 occur 2 times, so 2 here. So this is how we are getting in the term in the denominator. And on simplifying the numerator, you will have 1 plus 2 times 2 plus 3 times 3 plus 4 times 4 plus 5 times 5, 6 times 6 plus 7 times 7. And this is nothing but 1 plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus 7 square divided by 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. And in the previous slide only, we discussed the formula to find the sum of n natural numbers and sum of squares of n natural numbers. So it will be 7 times 8 times 15 upon 6 upon 7 times 8 upon 2. And on simplification, you will have average equal to 5. So the correct option here should be option number B, that is 5. So moving ahead to question number 7. If the average of 20 observations is x1, x2, x3, dot dot dot, x20, and its average is y, then the average of x1 minus 101, x2 minus 101, x3 minus 101, until x20 minus 101. So what exactly we are doing here is, we have some data points, and it's suppose its average is y, then we are making change in the initial data set. We are subtracting 101. We are reducing each value, each data by 101. So then how the average will be affected when the each data point is subtracted by 101? That's exactly what question is trying to ask. So the concept that will be useful here is, if the same number is subtracted, if the same number, so the same number is very important here, is subtracted from the every term of the sequence, then the average will get subtracted. Average will get after subtracting the same number from the initial average. So if each digit, if data point is subtracted by some number, then the average will also reduce by that number. That's exactly what we are saying here. So the initial sequence was x1, x2 to till x20, and its average was given to us as y. So the final sequence will be x1 minus 101, x2 minus 101, and it goes on till x20 minus 101. So the initial average was y. So the new average after reducing 101 from each data point will be y minus 101. That's exactly what we wanted to find. So option that will be correct here is option number B, y minus 101. Moving ahead to problem number 8. The average of 126 numbers is 951. If each number is multiplied by 0.2 and added to 3.6, the average of new set of number is. So we have some set of data points, and its average is 951. So we have 126 observations, and its average is 951. And I am making a change in each data point. So I multiplied each data point by 0.2 first and added 3.6 to it. Then we are asking how the average is going to change. That means I'm asking, will the new average be 951 or something else? And if it's something else, then what is it? So the concept that will be used here is, if n1 is multiplied to every term of sequence and n2 is added to every term, then the initial average x will change to n1 times x plus n2. So the average of new set will be 0.2 times 951 plus 3.6. That is nothing but 193.8. So the correct option here will be option number A, that is 193.8. Let us move ahead to problem number 9. So if the average of x and 1 upon x not being 0 is m, then what is the average of x square and 1 upon x square? So the concept that will be used here is sum equal to average times of number of terms. So it is given that average of x and 1 upon x is m. So that means x plus 1 upon x upon 2 is equal to m. That is exactly what is given to us. So I can write it as x plus 1 upon x equal to 2m. And if I take the square both side, I will have x plus 1 upon x whole square equal to 4m square. So on simplification, opening the a plus b whole square, x square plus 1 upon x square plus 2 equal to 4m square. And we were interested in x square plus 1 upon x square. Then it will be 4m square minus 2. And what was the final destination? We wanted to find the average of x square and 1 upon x square. Then it will be calculated by dividing the sum x square plus 1 upon x square by 2. And the value of x square plus 1 upon x square is already known to us. That is 4m square minus 2. And when I divide it by 2, I will have 2m square minus 1. And it is option number C, that is 2m square minus 1. Let us move ahead to question number 10. The average of a number and its reciprocal is 4. Suppose I have a number A and another number generated by A, that is its reciprocal, that means 1 upon A, and I take the average, that means A plus 1 upon A, and the average of this thing is given to us, which is equal to 4. Then the average of its cube and its reciprocal equal to. So the concept that will be useful here will be the sum equal to average times of number of terms. Now, the question we did in the question number 9 was very similar to what we are going to do in question number 10. They both are very much alike. In that question, they gave x and 1 upon x, but here they do not directly talk about x and 1 upon x. They indirectly point towards it. They say the average of a number and its reciprocal is 4. It means if the number is x, then the average x plus 1 upon x is equal to average times number of terms is equal to sum. So x plus 1 upon x upon 2 is given to be 4. So it will be x plus 1 upon x equal to 8. So taking cube both side, so we are not actually squaring here. So we are taking cube here. So it will be x plus 1 whole cube equal to 8 cube. So x cube plus 1 upon x cube plus 3 into 8, it will be equal to 8 cube. So x cube plus 1 upon x cube will be 8 cube minus 3 times 8 will be 488, and dividing it by 2 will give me the final answer, that is 244. So 244 is the final answer here. That is option number D, 244. So moving on to question number 11. If A, B, C, D, E are 5 consecutive odd numbers, then their average is. So we have 5 consecutive odd numbers and we are interested in finding their average. So average of consecutive odd numbers or term in a sequence is equal to middle term. This concept we have multiple times. We have solved problems based on this same concept multiple times. So the average will be C. And since these are consecutive even numbers, consecutive odd numbers, so it is A and it will be A plus 2 and it will be A plus 4. Correct? So the average will be middle term, that will be A plus 4, option number D. So moving ahead to problem number 12. If A, B, C, D, E, F, G are consecutive even numbers, J, K, L, M are consecutive odd numbers, then the average of all these number is. So the concept that we are going to use here is, if the average of n1 numbers is a1 and average of n2 numbers is a2, then the average of total numbers n1 n2 will be given by n1 a1 plus n2 a2 upon n1 plus n2. So the average of consecutive odd number of term in the sequence is middle term. We have already discussed this. So sequence 1 is a b c d e f g and its average is d. And the sequence 2 is JKLMN and its average is L. So both of them have odd number of terms. So the average will be the middle term, that is D. Same goes here. The average will be middle term, that is L. So the overall average will be 7 times of D plus 5 times of L upon 7 plus 5. So here we are using this formula to obtain the total average. So total average will be given by 7D plus 5L upon 12. That is option number C, 7D plus 5L. Moving on to question number 13. The average of 5 consecutive even number is M. So 5 consecutive even numbers is given to us and their average is M. If the next 5 even numbers are also included, then the average of 10 numbers will be. So what will be the new average? That is what we are interested in. So the average of consecutive odd number of terms in a sequence is the middle term that we have already seen. And the average of consecutive even number of terms in a sequence is equal to average of middle two terms. Okay. So 2, 4, 6, 8, 10. So the middle term here is 6. Correct? So new average will be M plus 5. And again taking 5 more even terms, it will be 12, 14, 16, 18 and 20. And we wanted to find the average of this 10 numbers. So earlier the average was 6 and now the average will shift to the middle number. Okay, it will move 5 ahead. So it will be 11. So M plus 5 is the correct answer, that is 11. Moving on to problem number 14. The average of 4 consecutive even numbers is 27. By adding which does the average become 28? By adding which number does the average become 28? So the average of consecutive even number of term in the sequence is given by average of middle two terms, and the average of consecutive odd number of term in the sequence is given by middle term. Okay, so these two concepts are very important and have been used repetitively in questions again and again. So we are given that the average of first 4 consecutive even number is average of 4 consecutive even number is 27. That is given to us. Okay. So the middle term will be 4 consecutive numbers are given. So this is the case. So it will be 27 here and the left side will be 26 and right side will be 28, because when we take the average of 26 and 28 we get 27. Okay, and next thing, that is by adding which number does the average become 28. So which number should be added so that the new average is 28? So the new average will be 28 when it is in between the numbers 26 and 30. So when you add 30 and 32, the average will become 28. So we have to add next even number here. So moving on to problem number 15. So the average of four consecutive odd natural number is 8 less than the average of three consecutive even natural numbers. If the sum of these three even numbers is equal to the sum of above four odd numbers, then the average of four original odd number is. The concept that will be useful here is sum equal to average times number of terms. So let us take four consecutive odd numbers. Average of their four consecutive odd natural number is x, and the sum equal to 4x. So now let us take three consecutive even natural number. Average of their three consecutive even natural number equal to x plus 8, and the sum will be x plus 8 times 3. So it will be 3x plus 24. So according to the question, we have 4x equal to 3x plus 24, and we get x equal to 24. So option A is correct here. So that would be all for this part, and solve all the questions by your own that we have studied in this lecture. Thank you very much.